Hello and welcome. This is Learn Kotlin lesson number 1 and Kotlin Basics part 1. I will talk in this video about vals and vars, type inference, and basic types. So, vals and vars. Kotlin have two types of variables with respect of mutability. Vals are immutable and vars are mutable. When we say that vals can only be initialized single time, okay? And vars can be initialized and then can be reassigned. Let's see an example. Here in the code I type val, the variable is called n123. So this is a val. If I say n is equals to 4, 5, 6 after this first line, Kotlin will complain. Val cannot be reassigned. Okay, this if you came from Java, this is like a final variable. Okay, in the other hand we have var, let's say a is equals to 1, 2, 3, and then we try to reassign. Now Kotlin allows us to reassign a var. Okay, so val cannot be reassigned and var can be reassigned. About type inference. Before talking about type inference, let me talk about a simple concept. Kotlin is a strongly typed language. And what is strongly typed language? Let's see in code. Here again, let me say that we have a var that is called a and it is 1, 2, 3 again. Well, you think it's a var, I can reassign the value, okay? So let's do that, but instead of giving it a number, I will give it a text ABC. Now the compiler is complaining because ABC it's not a number, it's a text. So you can reassign values to var, right? But because the type of the data is different, you cannot change it. Okay, so this is a number. In this case, specific case, it's an integer, and this is a string, is a piece of text. Okay, you cannot change the data type of a variable, and this is strongly typing the language, okay, to avoid some future errors. Now that we know this simple concept, I don't know if you noticed, but going back here to the code, I did not say that this is a number. Kotlin just assumed that this is a number, this is an integer. Type inference. When Kotlin tries to guess the data type of a variable. In the other hand, you can say it explicitly, saying that the var b is an integer and its value is 1, 2, 3. Okay, so this is explicit type declaration. Okay, and the concept of type inference is just that. When Kotlin compiler tries to guess the data type of your variable. Well, type inference is used when you use vars, you use vals, you have closures and single line functions. I will not talk much about them in this video, okay, because this is a future material. Let me show you what it means. It means that, for example, I will declare a closure, a val a that is equals to open brackets, and I say that it has an x that is of type int and saying that x plus 1. Here I'm declaring a lambda expression. This is a lambda expression, and I am saying that this lambda expression receives an integer, and I'm not saying anywhere that it returns an integer, but Kotlin looks at this expression and he sees that this is an integer and it's adding another integer, so the return will be another integer. In this case, in this specific scenario, Kotlin compiler is guessing, inferring the return type of this closure. Okay, this is a closure. And now I will show you inline function, right? Inline function, for example b, it has a parameter of type int and it will return the sum of x plus 1. So in this scenario, this is inline function, okay, a single inline function. In this scenario is exactly the same thing that it does in the closure. Okay, it knows that receives an integer, then it adds to that integer another integer, so the result must be an integer. Okay, so Kotlin is inferring the result. Basic types. In Kotlin, everything is an object. If you are from Java, you know that in Java you have primitive types and objects. Also, you know that Kotlin runs on a JVM, Java Virtual Machine, so the code from Kotlin must run on the JVM. But here in Kotlin, they decided that do not have primitive types, they just have objects. Okay, so in Kotlin everything is an object. Okay, for you that are new to programming, this concept object will be explained in a future video, and I ask you to not get scared about this, because you just started. Okay, so let's move on, right? Compiler have to map the types to primitive types of JVM, like I said before. For example, if you have an integer in Kotlin is an object, and in the JVM it is a primitive type, so it must convert that object into primitive types. Okay, now I will talk about numbers, and we have 6 types of numbers. The long with 64 bits, the int with 32 bits, a short 60, hexadecimal, right? A byte with 8 bits, binary, a double, 64 bits, and this case is a floating point, the first one that have a floating point. Okay, and we have a second one with a floating point too, but it has 32 bits. Okay, so if you notice here, the int and the double are different from the rest. They don't have, for example, the long have an L at the end, and the short is written in hexadecimal with the X here, and the byte have a B for binary, and the float have this F. Okay, these are the default for type inference in a Kotlin compiler. Let's see what I am saying with this. For example, you have a val A 1 2 3, a val B 1 2 3 L, this is a long. The first one is a int, and this is a long value. Also, you can declare longs like saying explicitly that this is a long, so saying like that. So in this scenario you don't need to add this L. Okay, there is another scenario. Let's say that we have a val d that is equals to a. Sorry. If I say this, well, if I say that the val d is specifically a long value, and because a is an integer, Kotlin will complain about this. So in this scenario you must do too long. Let's move forward with this, and you may ask why Kotlin compiler doesn't convert numbers by its own, right? And the answer is to ensure that there are no future errors. We have a val g that is equals to 12.34. This is clearly double, right? And imagine that you want to convert this double into an integer, right? And you say that val a, that is an integer, is equals to g. Kotlin will complain because the data type of g is double and a is an integer, so you must say to int, right? And let me print line a. It's printed 12, but imagine this situation. You have a val b that is an integer, and you want the number to be rounded to 13 and not 12, because it's a floating point number and it can be higher. The rules of your business can demand this kind of situation. So in this scenario you say that Kotlin dot mat dot sale g, this is rounding up the number to 13, and then you convert to integer. Okay, and now if I print the b, and now we have 13, right? So this is a way of ensuring the compiler doesn't do the job for you. Not converting automatically the g into an integer is ensuring that you decide how the conversion will go. If it is the default conversion, this scenario, or if you want to apply some specific rule to that conversion in this scenario. Okay, so let's move on. Now I will talk about bitwise operations. Shift left, then shift right, unsign shift right, logical AND, logical OR, logical exclusive OR, it's also known as SHOR, and inverse. This is a unary operation, so it doesn't have this kind of keyword. Okay, so you can use the keyword like this, or you can use like a method, a function, right? Now the next thing to talk about is booleans, and booleans have the negation, not or using the function like, the conjunction, the AND. It also has a AND function, but it's slightly different. I will talk about it in the future. And this junction, OR. And this is not a bitwise operation, okay? And also an important thing about this is that this performs short circuit evaluations. What this means, I need some code For example, you have a var a is equals to true, and you say that you have a var s that is equals to a or true. In this scenario, since this one is true, this one will not be evaluated. This is the short circuit. Okay, for example, this is different from bitwise operations, a or true. The bitwise operation must be evaluated always. So let's prove that this is in the way that I am saying to you, right? So I declare here a closure, for example my func, that don't receive any parameter, but it returns a boolean. Okay, and this is equals to print hello 𝗀𝘂𝗯. This is used to separate two expressions in the same line, and it's hiding. So this closure does, it prints the hello and then returns true. Okay, let's change the code here to call this function, and here to call this function again. So since let me comment this one, the first one, with the bitwise operator, and let's run. Let's see, and nothing happens. Okay, if I change this to false, okay, let's see the result, and now we have this hello. Okay, so in this scenario, this function is run because the first expression evaluates to false, so false or, and it's trying to find the true, right? Let's change this again, and let's comment this one, and this is a bitwise operation. This is different from the first one. This is a bitwise operation, and the expression will be always evaluated. Let's call it hello2 and run, and we have this hello2, so this means that this function is run. Okay, so this is different. Let's move on here. We have chars, and what is a char? A char is a single character. Okay, and if you want to represent Unicode chars, you can represent by numbers. Let me show you. Let's say that var a is equals to 2600, and let's print line a, and also I want var b is equals to 26 f and 4, and copy, paste b, and let's run this, and we have this output, a boat and a sun. Okay, so this is an example of Unicode char. Important thing here, char is not a number like in Java. For example, if you want to get the ASCII code, you must do, for example, this is the k. If you want to print the ASCII code of k, you must say a to int. You must convert it into an integer. And let's run. And k is 107. Okay. So let's move on. The next type is strings. Like I said before, it's a piece of text, and an important thing about this is strings are immutable, like in Java. Okay, so once you have a string, you cannot change that string. Let me show you For example, you have a var that is a mutable variable, and it's called a, and you say that a is equals to abc, and then you say that the a is equals to a plus hello. If you print the variable a, it will output the abc hello and abc hello. So you say, well, strings are immutable and it changed, right? Not actually. If you declare a variable b that is equals to a, so b is equals to a. If a is changed, b must change too, right? Let's see if b change. Let's go to run this. The value of b is abc, just abc. So strings are immutable. The thing is, the variable a is now pointing to another string, not the same string as b. Okay. Also, you can have strings with double quotes and triple quotes. The first one known as escaped string, and the second is a raw string. Let me show you an example of these two. For example, escape string a is equals to double quote and a b c. If you want to print a new line, you must say this new line and new line. So you are escaping with n. This means a new line. If I print line the variable a, it will return 3 lines, one with a, the second with b, and the third with c. Right? A, B, C. And this is a escape string. And raw string var b is equals to 1, 2, and 3, a, b, and c, and then I close. This is a raw string, which means that go away. You don't need to use escapes to say that these have a new line. Let's run. Oh, sorry. I don't know if it will get these codes. I did a big mess. But it's you know that is this b because it have this space. Okay, so the raw string is declared with triple k, and you don't need to escape. The escaped one, the escape string needs escapes to have new lines of text. So going back and moving on. Well, strings can be accessed by index. What this means? This means that if you go here to the code and we declare a variable a is equals to a, b, c, you can print line a at index 1, the b value. Let's run. It's running, and we have a b value. It's the character at the index 1. Index starts always by 0, 0, 1, and 2. Okay. Now our final type, I think. Arrays. Arrays can be initialized with library functions, and they can be initialized with a size and with a function that generates the value. And for you that don't know what what is an array? An array is a sequence of values. Instead of declaring multiple variables, you just have one variable with multiple values associated with it. Okay, so for example, var a is equals to array of 1, 2 and 3, and because in Kotlin everything is an object, you can have a string to hello, for example. And if we print for each element in a, in the text a, we want to print the element. So this is using the function. Go here. We're using a function library. Okay, this scenario, and we have the output of 1, 2, 3 hello. Okay, next, using the size and the generator function, var b is equals to array. Instead of array of, we have the size of 4, and we have a function, in this case is a closure, where we say that everything is zeros. So instead of for each a is for each b. Let's run this. We have 4 zeros. Also we can say that is instead of 0 is k. Let's see the result. We have 0, 1, 2 and 3. If we multiply these, we will have an array of 0, 2, 4 and 6. 0, 2, 4 and 6. Okay, so let's see the next thing. Well, we have another third way of declaring arrays is using int array or double array, etc., to avoid boxing and after unboxing on the JVM. Okay, let me show you for you to understand. Instead of array, we call this int array. So, and it executes, and it's for you as a programmer, this is very this is equal. Okay, but for the JVM this is optimized. Okay, instead of boxing the values, and the name boxing and unboxing means that boxing is creating from a primitive type, is transforming it to an object, a reference type. Unboxing is taking an object and transforming it to a primitive type. Okay, so if you have performance issues, and if you use a primitive type like an integer or a double, a float, a boolean, you can use this kind of arrays. Okay, and this is the end. Thank you for watching, and see ya.